At the center of every atom lies the nucleus, a dense cluster of protons and neutrons. In most everyday atoms, this nucleus is stable, held together by balanced forces, but some nuclei are unstable, either too big or with an off-balance mix of protons and neutrons. These unstable nuclei seek stability by releasing energy and particles, a process called radioactive decay. The energy and particles released are what we call nuclear radiation. This process is natural, happening in the Earth's crust, and even within our own bodies. When you hear nuclear radiation, think of atoms trying to reach a stable state, not just power plants or sci-fi. The atom sheds excess energy to settle down, emitting different types of radiation. The three main types are alpha, beta, and gamma radiation. Each type is a unique package sent out from the unstable nucleus. Understanding these helps us grasp the very fabric of matter. Let's explore what makes each type of radiation unique. The journey starts with alpha radiation. Alpha radiation is the heavyweight of the atomic world. An alpha particle is a cluster of 2 protons and 2 neutrons, the same as a helium nucleus. When a nucleus is too large, it spits out an alpha particle to slim down, transforming into a new element. Alpha particles are big, slow, and carry a double positive charge. They're like bowling balls, highly ionizing, knocking electrons off atoms as they pass, but they lose energy quickly and can't travel far, just a few centimeters in air, stopped by paper or skin. Externally, alpha radiation is harmless. Your skin blocks it completely. The real danger is internal. If alpha emitters are inhaled or swallowed, they cause intense localized damage to cells and DNA. That's why alpha sources in smoke detectors are safely sealed. Their high ionizing power and short range make them perfect for detecting smoke, but safe when contained. Alpha radiation is a powerful force, dangerous inside, harmless outside. Next, let's meet the nimble beta particle. Beta radiation is the middleweight of the trio. Here's how it works. Beta radiation is a fast-moving electron ejected from the nucleus. It's created when a neutron transforms into a proton, releasing a high-energy electron. Beta particles are tiny, light, and negatively charged, zipping out at up to 60% the speed of light. This process changes the atom into a new element, moving it up the periodic table. Beta particles are moderately ionizing, less than alpha but more than gamma. They travel farther than alpha particles, passing through paper but stop by thin aluminum. Externally, beta radiation can penetrate skin and damage underlying tissue. Internally, it spreads its damage more widely than alpha, but less intensely. Beta radiation is used in industry to measure material thickness, with detectors adjusting machinery in real time. It's a versatile tool, more penetrating than alpha, but still manageable with proper shielding. Now let's look at the most energetic form, gamma radiation. Gamma rays are pure energy. Gamma radiation isn't a particle, it's a wave of pure energy, a high-frequency electromagnetic ray. Gamma rays are released when a nucleus sheds excess energy after alpha or beta decay. They have no mass or charge and travel at the speed of light. Gamma rays interact weakly with matter, making them the least ionizing but the most penetrating. They can pass through the human body and even thick walls. Only dense materials like lead or concrete can block them. Externally, gamma radiation is the most dangerous, reaching deep into tissues and organs. Internally, it's less hazardous. Most gamma rays pass right through the body without interacting. Gamma rays are used in medicine to sterilize equipment and target cancer cells deep inside the body. Their penetrating power is both a risk and a powerful tool. Gamma radiation is the invisible messenger, hard to stop, but essential in modern science and medicine. Now let's compare the dangers of these 3 types of radiation. How do they affect us from the outside and the inside? Let's break it down. Here's what you need to know. Radiation exposure comes in 2 forms: irradiation and contamination. Irradiation is exposure from an external source, like standing near a heat lamp. Walk away, and it's over. Alpha radiation is harmless outside. Your skin blocks it. Beta can penetrate skin, causing surface damage. Gamma is the most dangerous, passing deep into the body. Contamination is when radioactive material gets on or inside you, through breathing, eating, or wounds. Now, the danger flips. Alpha becomes the most hazardous, causing severe, localized damage if inside your body. Beta is a moderate internal hazard, spreading its effects more widely. Gamma, surprisingly, is least dangerous internally. Most rays pass through without interacting. The key to safety is understanding the type of radiation and whether it's inside or outside your body. Proper shielding, distance, and containment are essential. Next, let's see how we put these types of radiation to work for us. Radiation isn't just a hazard, it's a powerful tool. Despite the risks, radiation has countless beneficial uses. Alpha radiation's high ionizing power and short range make it ideal for smoke detectors, safe when sealed, sensitive to smoke. Beta radiation's moderate penetration is perfect for industrial quality control, measuring the thickness of paper or foil without contact. A beta source and detector monitor material thickness in real time, allowing precise adjustments. Gamma radiation's deep penetration is harnessed in medicine to sterilize equipment and target cancer cells. Each type of radiation is matched to its strengths, turning potential danger into practical benefit. By understanding their properties, we use radiation safely and effectively. Science transforms risk into reward. Now let's sum up what makes each type unique. Here's the final comparison. Alpha, beta, and gamma radiation, three messengers from unstable atoms, each with a distinct personality. Alpha is the heavyweight brute, powerful but short-ranged, dangerous inside, harmless outside. Beta is the nimble middleweight, moderately penetrating, moderately ionizing, useful, and manageable. Gamma is the invisible phantom, least ionizing, most penetrating, a risk from afar, but a tool for healing. Understanding these differences is vital for science, medicine, and safety. We harness alpha for smoke detectors, beta for industry, and gamma for medicine. By knowing their strengths and weaknesses, we protect ourselves and improve our world. Alpha, beta, and gamma, fundamental forces shaping our universe. Demystifying them helps us navigate safely and wisely. The atom story is one of balance, transformation, and opportunity. And it all starts at the heart of matter itself.